Good afternoon, children.
Good afternoon, ma'am.
So yesterday we discussed about how to find the mean variance of a Poisson distribution, isn't it? Poisson distribution is a limiting case of binomial distribution where n is very large. Where n is very large, p is probability of success is very, very small. Probability of success is very small. And n into p will be equivalent to n into p is equal to np is equal to lambda. np is equal to lambda. For a Poisson distribution, mean is same as expected value is same as variance. All are same. Okay, now let's do some questions based on this. You take your textbook. Okay. Did you complete the questions from binomial? You tried those questions from binomial or not? Today, we will be discussing few questions and the remaining questions you have to complete it from Poisson. Try the questions, including examples and exercise. Okay, now take the second question. Yesterday itself, we are discussing the second question. I think you copied this question, second question. Take your textbook, exercise 9.5, second question. Exercise 9.5, second question. Read the question. Yesterday we wrote the question, and as we have not learned the formula, I think we stopped with that, isn't it? Now we have learned the formula, we are going to solve it. Look at the question. Suppose a book of 614 pages. Suppose a book of 614 pages contains 43 typographical errors. So typing errors are there. A book is there with 614 pages and there are 43 errors. If these errors are randomly distributed throughout the book, this error is okay throughout the book. Throughout the book, we can find out 43 errors. What is the probability that 10 pages selected at random? If you take 10 pages, it will be free of errors. Free of errors means no error at all. Okay. So from reading this question, go through it. What is given? A book of 614 pages contains 43 errors. So 43 errors are there. Out of how many pages are there? 614. So what is the probability of finding an error in one page? What is the probability of finding an error in one page? What is P? Finding error in one page will be same as 43 by 614. Is it correct? 43 by 614. Now what is given if you look at the book and we take the, okay, what is the probability that 10 pages? Okay, when you take 10 pages, n is equal to 10. When you take n as 10, when now 10 pages are selected at random, what will be the free of errors? What is the probability that there will be free of errors? N is 10. In order to define the Poisson distribution, P of x is equal to k means what is the formula we have learned? E raised to minus lambda, lambda raised to k by k factorial, where k is equal to 0, 1, 2, etc. Is that no? E raised to minus lambda, lambda raised to k by k factorial, where k is 0, 1, 2, 3, etc. We don't know lambda. First, we have to find out lambda. What is lambda? Lambda is equal to NP. So 43 by 614 into 10. So simplify this and find out what is lambda. Make it fast. Divide this and find out what is the value. You find out what is 43 by 614. 43 divided by 614. So it is not possible. Then what you will do? You add 0, 0 points, gain 0. And simplify this. How many times it will go? Fill this. So it is 43, isn't it? So what is 6.4 into 7? 7 4s are 28, 2, 9, 4, 2, isn't it? 7. So this is enough. Only this much place is enough. After decimal, one non-zero value, if you get, you can stop. 0.07. So okay, don't go for dividing. After that, one place is enough. So 0.07 into 10, which will be 0.7. Lambda value is 0.7. So when you substitute it, e raised to minus 0.7, lambda raised to k by k factorial. P of x is equal to k is this formula. Now what is given? What we are asked to find? We want to find the probability that is no error at all. There is no error. There is no error means what you have to find? What is the value of k? K is 0. K value will be 0. So when you put 0 here, P of x is equal to 0. Why we put 0? What is asked? No error. Okay. So when you put x is equal to 0, e raised to minus 0.7, lambda raised to 0 by 0 factorial, which will be same as e raised to negative 0.7. Substitute the value. Substitute the value and okay, find out the value from the table and check whether the answer is correct. Give me the answer. What is the value, Aishwarya? E raised to minus 0.7 from the table?
0.497.
0.497. Okay. Is it clear? Is it okay? Shubham? Shubham? Shubham, is it okay how to find out this distribution? Poisson distribution. Is it clear? Shubham? Yes, Shubham? Shubham? Okay, what about the others? Anila, Mohanan, Aditya, is it clear? Femina, is it okay?
Yes, ma'am.
Okay, now let's do the next question. We are going to do the fifth one. So 2, 3, 4, you tried that questions. Probability is given, n will be given. First you find lambda, then apply that. Okay, similar questions only. All the questions are similar. Okay, I've selected few important questions and I'm solving. Look at the fifth one. The probability, read the question. One of you read the question. Aparna, read the fifth one.
The probability that a man aged 35 years will die before reaching the age of 40 years may be taken as 0.018. Out of a group of 400 men now aged 35 years, what is the approximate probability that 2 men will die within the next 5 years?
Look at the question here. Okay, these are all some very rare incidents, isn't it? Okay, earlier also when we learn about this concept, we learned. Okay, it is not a Okay, Poisson is used for describing rare events. That is why we get the probability as very, very less, very small. Okay, look at here. The probability that a man aged 35 years will die before reaching the age of 40 may be 0.18. Okay, so probability is given. Okay, here the probability is given. What is the probability here? 0. The probability is 0.018. Now, out of 400 men, okay, we take a sample of 400 people. So n is 400. Out of 400 people, now what is when we look at this? Okay, out of 400 people, now aged 35 years, what is the approximate probability that 2 men will die within the next 5 years? If you take 400 people, what we have to find? At least 2 men will die. What is the approximate probability that 2 men, okay, it is not at least, it is given 2 men will die. What is the probability that 2 men will die? Here, look at there. Here it is not given as Poisson and all. But you have to understand this one. It is a rare event. Okay. So P is 0.018. And look at the number of people taken here, 400, which is very big number. So then we have to find out the Poisson distribution. In Poisson distribution, the first thing you have to find is lambda. What is lambda? Lambda is NP. It is 400 into 0.018. So what is the value of lambda? Yes, calculate and tell me. Is it 72? Is it 7.2? 0.018, 3 places. So after decimal, if I put 3 places, is it correct? Is it correct, Aishwarya?
Yes, ma'am.
So lambda is 7.2. Now write the distribution. What is the formula for binomial distribution? P of x is equal to R. Okay, all the symbols you should get familiar with it. P of x is equal to R is e raised to minus lambda, lambda raised to R by R factorial, where R takes the value 0, 1, 2, etc. Here we want to find the probability for x is 2. When x is 2, we have to calculate. So it is e raised to minus 7.2. 7.2 the whole square by 2 factorial. Is it correct? Now what is e raised to minus 7.2? Apply the value from the table. What is e raised to minus 7.2? E raised to minus 7.2 is 0.007, isn't it? 0.0007 into 7.2 into 7.2 by 2 factorial. 2 factorial means it is 2. 7.2 into 7.2 by 2. Now simplify this and give the answer. 2, if you cancel this one will be 3.6. So 0.007 into 3.6 into 7.2. Multiply this and find the answer. What is the answer, Aishwarya? Calculated.
It it 0.018144?
0.0
181.
181. 181. But here I think it is 0.019 is the answer given. What is your answer, Anila?
0.018.
18. Okay.
Ma'am,
Yes.
ma'am, in the question it is said use e raised to minus 7 point is equal to 0 point given.
Okay,
a certain
there the
value.
value is given 747. Okay. If you take more places, accordingly the value will change. Okay. Okay, we wrote only the first. Okay, from the table only this much is given, isn't it? But here it is given. Okay, then you have to put that value. Now the method, is it okay? When you do this, when you do this question again, once again, you try that with 0.0074. So now that one I didn't notice at all. I just read the question and we took the value from the back. But for the exam, you look at there. Okay, most for the exam, anyhow, table they will not give. I think like this, they will give the value within the side. Okay, is it clear, Femina? Is it okay? Poisson?
Yes, ma'am.
Now look at the next one, 8th question. Read the question, 8th one. After doing the 5th one, we are going to do the 8th question. Look at the question, 8th one. What is given in the 8th question? Read the question. Anila Mohanan, read the question, Anila.
At a busy traffic intersection, the probability P of an individual car having an accident is very small. Say P is equal to 0.0001. However, during a certain part of the day, a large number of cars, say 1,000, pass through the intersection. Under these conditions, what is the probability of 2 or more accidents occurring during that period?
Okay. So look at here, at a busy traffic intersection, the probability of an individual car having an accident is 0.0001. However, during a certain part of the day, a large number of cars, say 1,000. Okay, n is given as 1,000. Look at here, n is very large. Passes through that. Under these conditions, what is the probability that 2 or more accidents occurring during that period? That means you have to find P of x greater than or equal to 2. And one value is given, E of negative 0.1 is 0.9048. Okay, we are asked to find P of x is greater than or equal to is question mark. How to do this? First, you find out lambda, isn't it? Lambda is NP. So 1,000 into 0.30 followed by 1. So it will be the value of lambda. 3 zeros are there. The lambda will be 0.1, isn't it? Now write the Poisson formula. P of x is equal to R is e raised to minus lambda, lambda raised to r by r factorial. Here it is e raised to minus 0.1, 0.1 raised to r by r factorial. Now listen children, here we are asked to find x greater than or equal to 2. Greater than or equal to 2 means it goes on. The value goes infinitely. It may be 3, 4, 5 and so on. So what we learned yesterday, x is greater than or equal to 2 means we can find this as, how will you calculate this? X greater than or equal to 2 will be same as 1 minus P of x less than 2. Is it correct? It's negation, complementary. You're writing the complementary. It is 1 minus P of x less than 2, which is same as P of x less than 2 means what are the possibilities? X can take 0, x can take 1. P of x is equal to 0 and x is equal to 1. You substitute the values there. So when x is 0, so 1 minus, when you put x is 0, e raised to minus 0.1, 0.1 raised to 0 by 0 factorial plus x is 1. E raised to minus 0.1. 0.1 whole raised to 1 by 1 factorial, isn't it? So we can take e raised to minus 0.1 as common. So here we will get 1 plus 0.1. Is it correct? Now substitute the values. Values are given there. E raised 1 minus, what is e raised to 0.1? E raised to 0.1, the value is given as 0.9048 into 1.1. Is it correct? Anila Mohanan, is it correct up to this?
Yes, ma'am.
Now multiply this, subtract and find the answer. What is the answer, Aishwarya?
0.00472.
0. 0.047. Aparna, is it correct, Aparna? Femina, is it correct? Femina.
Yes, ma'am.
Aditya Satyan, okay? Is it clear?
Yes, ma'am.
Shubham? Shubham. Okay, shall we move on to the next one? No, okay, here in this type of questions and all, there are no lengthy calculation. Just you have to identify and find out lambda and substitute in the formula. From the table, you can use the value there. Now, let us do the next one, 11th one. 11th question. 11th question. Read the 11th one. A box contains 200 tickets. A box contains 200 tickets, each bearing one of the numbers from 1 to 200. So, 200 tickets are there with the numbers 1 to 200. 20 tickets are drawn successively with replacement from the box. We take 20 tickets from the box. Although 200 are there, we try, okay, although 200 are there, we take only 20. We consider only 20. So, n is 20. Okay. 20 tickets are drawn successively with replacement from the box. What is the probability that at most 4 ticket bears a number divisible by 10? Probability is not given. Instead of that, what is given? We select a ticket. What is the probability? It is divisible by 20. So here, P denotes a number divisible by 20. Okay. Between the numbers 1 to 200. Between the numbers 1 to 200, how many numbers are divisible by 20? What will be the answer? Okay, it is given. Number is from 1 to 200. So 1 is included, 200 is also included. So from 1 to 200, how many numbers are divisible by 20? 20 into dash is 200. 20 into
10.
10. So what is the probability? Probability of getting a number divisible by 20 is 10 by 200, which is 1 by 20, which is equivalent to 0.05. P is 0.05. Now find out lambda. Lambda is equal to NP, which is 20 into 0.05. Substitute this, find out what is lambda. 20 into 5. 20 into 5. Are you getting 1? Is it correct? 1? So lambda is 1. If lambda is 1, write the probability distribution. P of x is equal to k is equal to e raised to minus lambda, lambda raised to k by k factorial. So e raised to minus 1, lambda raised to k by k factorial. Now what is asked? Find the probability that at most 4 tickets. At most means what? Maximum 4. X is less than or equal to 4. So that means x may be 0 or x is equal to 1 or x is equal to 2 or x is equal to 3 or x is equal to 4. X is equal to 0, 1, 2, 3, 4. So substitute the values there. When x is 0, 1, 2, 3, 4. When x is 0, what you will get? Lambda. Okay. Lambda is 1. So e raised to minus 1, 1 raised to k. So it will be 1, e raised to minus 1 by k factorial is enough, isn't it? So k is 0 means here 0 factorial plus e raised to minus 1 by 1 factorial plus e raised to minus 1 by 2 factorial plus e raised to minus 1 by 3 factorial, 4 factorial. So from all these things, we can take e raised to minus 1 outside. So 1 by 1 plus 1 by 1 plus 1 by 2. So substitute the value of e raised to minus 1. What is the value of e raised to minus 1? The tape, is it given there? No. You have to use the table and you have to write the value. Then here, denominator also take the LCM, simplify and find out the answer. Aparna, is it okay, Aparna?
Yes, ma'am.
So once we complete the portion, I'll send the sample paper. You have to take the printout of the sample paper and you have to keep it with you. Once we complete the portion, I'll send. Okay, that is why. Okay, whether I have to send it to you early means you can tell me. Okay? Huh? If you have to go out and take the copy and all means, I'll send it earlier. Send it earlier means, okay, by Monday, I think I'll base Monday evening, I'll post it because once we complete the portions, I will be discussing the sample question paper. After that only we'll start with the revision. What's the value of e raised to minus 1, Aparna?
Ma'am, 0.368.
0.368 into 1 plus 1 is 2, 2 plus 1 by is 5 by 2, plus 1 by 6, plus 1 by 24. Again, take the LCM, simplify. So is it 0.368 into 65 by 24? Will it be like this?
Yes, ma'am.
No, I think you can cut short or simplify it. Okay, once again, I'll mark your attendance. Finish it fast, children. Finish it fast. Okay. Is it over? Okay, right. The next one we are going to solve is 15th question. 15th one. 15th one. Look at the question. 15th one. For a Poisson distribution, 3 times P of x is equal to 2 is equal to P of x is equal to 4. 3 times P of x is equal to 2 is equal to P of x is equal to 4. You have to find P of x is equal to 3 and e raised to minus 6 is given. Okay, it is given, it is a Poisson distribution. So first you write the formula for Poisson distribution. P of x is equal to r means e raised to minus lambda, lambda raised to r by r factorial. Is or no? Huh? So when you put P of x is equal to 2 means what you will get? 3 into x is equal, okay, here it is the value of r, isn't it? So e raised to minus lambda, lambda raised to 2 by 2 factorial is equal to e raised to minus lambda, lambda raised to 4 by 4 factorial. Is it correct, children? Up to that, is it okay? So both the sides we can cancel e raised to. So 3 into lambda square by 2 factorial means 2. Is lambda raised to 4 by 4 factorial. 4 factorial means 1 into 2 into 3 into 4. So here 1, 2 will get cancelled. Lambda square, if you cancel here also you'll get lambda square. 4 3s are 12. 12 3s are 36 is equal to lambda square. Therefore, what is the value of lambda? Lambda we can take as 6. Lambda is NP. It will not be negative. It will be a positive quantity only. N is number of items and P is the probability. Probability will not be negative. So we can take lambda. Although we are getting two values here, we take positive 6. Lambda is 6. Now what is asked? You are asked to find P of x is equal to 3. So P of x is equal to 3 means e raised to minus lambda, e raised to minus 6, lambda raised to 3. Lambda is here 6 raised to 3 by 3 factorial. Substitute the value and simplify this. So in between, some questions we have not discussed. I'm going to give that questions to each one of you today's homework, and you have to solve and you have to send it to me. Aishwarya, 3 and 4. Aishwarya, 3 and 4. Anila, 6 and 7. Aparna, 9 and 10. 9 and 10. Then Aditya, 12 and 14. 12 and 14. Femina, 16 and 17. Karthik, you also do 16 and 17.
Okay, ma'am.
So once you do this, you have to send it to me. Okay, not only this questions you have to send it to me. Okay, the remaining questions, you have to do it in your notebook and keep it ready. Okay, you completed this part? Complete this one, e raised to minus 6 value is given, substitute it. 6 cube is 206, 1 6 will get cancelled, isn't it? It will become 6 square. E raised to minus 6, the value is given as 0.00248 into 36. Simplify this, you'll get the answer. Okay, so try to complete this question. Okay. In the next class, we'll start with normal distribution. For that also, you need the table. Okay. So do the questions, start learning, complete all the works, projects, assignments, and all, finish it and keep it ready for submission. Max assignments, which are the assignments I gave, do it. In index numbers also, I think I gave some assignment, 2 or 3 questions. Keep it ready for submission, all the assignments. Okay. Okay, children. With this, we end the session now. Thank you.